Precalculus, lesson 11.6, natural logarithms. We have 11.6, natural logarithms. We briefly mentioned this in the last lesson, but natural logarithm is log base e, log base e. And natural because the number e shows up all over the place in nature in all sorts of different relationships and in derivatives and integrals and wide variety of things like that. So log base e. Your calculator in most places that reference log base e write it as ln. I do a cursive kind of an L just so that it's more clear that I'm writing ln and not like in or 1n or something like that. So my norm is to do a cursive L with my ln. You might be wondering, well, if it's a natural logarithm in L, why is it ln? And it has to do with French. And French would be the logarithme naturel, basically, putting the adjective after the noun. And so that's what we have. We have ln for natural logarithm. We also have the anti-ln, the anti-natural logarithm, which just like we saw with common logs, the anti-common log, anti-log, is 10 to the x. The anti-natural log or anti-ln is e to the x. That's what's going on there. So you'll have some problems where it's just evaluate such and such. And those are just plug into your calculator with one like number 6, evaluate the natural log of 1 over 0.32, plug those numbers into your calculator. Same thing, anti-ln, anti-log, anti-natural log, use your e to the x button for that. And then you have some solve, where it's like use natural logarithms to solve. And let's just say we have something like, and let me do a couple things here. Let's say we have, we'll do one like that. Example, solve, and let's solve 18 equals e to the 3x. 18 equals e to the 3x. All right, x is trapped as an exponent. It's trapped as an exponent of e. That's your trigger for us, so we want to use natural logs. We're going to take the natural log of both sides. We're going to natural log of 18 equals natural log of e to the 3x. Now we can use our power rule, pull that around front. So we have natural log of 18 equals 3x, natural log of e. Now, natural log of e. Natural log, again, is log base e. So what we're saying is base e to what power equals e? Well, e to the first equals e. So this just becomes 1. All right, so then what we get is natural log of 18 equals 3x. Divide both sides by 3. So we get x is natural log of 18 divided by 3. Plug that into your calculator and let's see what we get. Natural log ln 18, divide that by 3, and we get 0.9635. 0.9635. Okay, there we go. So in other words, we're saying E, which again is roughly 2.71828. So we have e to the 3 times almost 1. So roughly a little over 2 to the third. Well, 2 cubed, 2.7, almost 3 cubed. So 3 to the third is 27. We have something a little less than 3, something a little less than cubed. So that makes sense that we would get, if 2 cubed-ish is 8, 3 cubed-ish is 27. That bird's eye view, that makes sense for an answer. How about one involving an inequality? So here we have 25 e to the x is less than 100. All right, we can isolate this e to the x expression by dividing both sides by 25. So that gives us e to the x is less than 4, right? 100 over 25. So then we take the natural log of both sides. Natural log of e to the x is less than natural log of 4. Power rule, x comes out. Natural log of e is 1. So we're just left with x on the left side. I'll go ahead and show that just to make sure it's clear. It's less than natural log of 4. Natural log of e, that's just 1. So we have x is less than natural log of 4. Evaluate that on our calculator. It should be a little under 2 because e is not quite 3, 2.7-ish. So we do natural log of 4, and we have 1.39. So we have x is less than 1.39-ish. I'm rounding. All right, that should do it for this lesson, but let me look just to make sure we solve something like that. You know how to solve something like that. Those are just plug in your calculator. Oh, you have some where it's solved by graphing. I'll go ahead and give one example of something like that. Let's say we have something like this. Let me erase this over here. Solve by graphing. And here's what we have. We have, where to go? 2 to the x equals root 3 to the x minus 2. Root 3 to the x minus 2. Well, rewriting this as an exponential, what do we have? We have 2 to the x equals 3 to the x minus 2 to the 1/2 power. Sorry, not rewriting it as an exponential, rewriting it as a fractional exponent. Well, solving by graphing, the idea here is we can take the left-hand side and say, let's let y1 equal 2 to the x, and let's let y2 equal 3 to the x minus 2 to the 1/2. You can input this in your graphing calculator, see what that graph is. You know what that graph looks like. 2 to the x, that's your parent function of exponential. Right, something roughly like that. And then root, let's see, y2 equals this, graph that, and where the graph of this and the graph of this intersect each other is the value of x that will make your original expression true. So instead of solve by graphing, that's the idea there. Take the left-hand side, make y equal that. Take the right-hand side, make y2 equal that. See where the two graphs intersect. That's the x value that will make the original equation true. And that should do it for lesson 6. Hope it goes well.